Hello guys, welcome back to Foolish Engineer. Now we'll go through the most important part which gives the clear distinction between the high voltage system and low voltage system, which is the isolation. It's the invisible bodyguard that keeps high voltage away from things and people that prefer not to get fried. The electrical isolation, especially galvanic isolation, is like putting an invisible wall between two parts of a circuit. It's like a moat around a castle or a thick window glass. Current can't flow through this barrier, meaning the high voltage side and low voltage side do not share a direct electrical connection. But here is the cool part. They can still exchange information and even power in a controlled way across that barrier. Imagine you and a friend are on the opposite side of a soundproof glass. You can't punch each other, but you can still communicate by writing notes or using sign language. Galvanic isolation works kind of like that. It lets signals or energy get moving without the high voltage crossing over. It's like social distancing for electricity. The high voltage and low voltage sections are kept physically a few millimeters apart, so they don't exchange any unwanted sparks. Here we use electromagnetic principle in case of galvanic isolation to pass on power or information. This barrier means any problem from the high voltage system doesn't go to the low voltage system and vice versa. Now, isolation is not just feel good measure. It's usually a physical thing. Using components like optocouplers, transformers or capacitors that pass signals without direct contact. We'll get into those gadgets later. One of the key reasons I started this YouTube channel is to bridge the gap between the outdated Indian education system and actual skills needed in the industry. Well, if you're a student, you can use and learn an industry leading EDS software, Altium, for free by using its student lab program, which narrows down this gap. You just need to use your university email to enroll, and you get a full student license, a full PCB design course, and a certificate recognized by top Indian core electronics industries. Altium isn't just one PCB design software, but it is a whole platform of capabilities for electronics design. I've personally used Altium since the start of my electronics journey, and I honestly recommend it. It's a fantastic way to enhance your skills and increase your chance of landing a job in a core electronics company. So don't miss this golden opportunity. First, why exactly do we go through all of this trouble? Can't we just connect stuff directly and save on fancy isolator gizmos? Well, not exactly. Let me count the ways isolation saves our stuff. There are multiple reasons. Each one is very important. The first most important reason is human safety. High voltage EV batteries can be hundreds of volts. If that kind of voltage accidentally reaches to the car chassis or a user accessible part due to lack of isolation, anyone touching it could get a potentially deadly shock. The BMS is usually connected to our vehicle network like infotainments, steering electronics, or diagnostic parts. Without isolation, that high voltage could sneak out where humans are. So if we touch it, zap.
खत्म बाय बाय टाटा गुड बाय गया
Isolation ensures there is a protective barrier so the high voltage doesn't directly touch to the low voltage circuits that human might interact with. The BMS itself has delicate electronics like microcontrollers, sensors, and communication chips, usually running at 5 volt, 3.3 volt, or similar. These are like the pet hamsters of EV world. Cute, small, and extremely vulnerable. If high voltage crosses into their territory, we'll get the magic smoke out of those chips instantly. Isolation is the bodyguard that keeps 400-volt bullies from beating up these 5-volt kids. In short, isolation protects sensitive electronics from instant death by high voltage. The BMS often needs to communicate between high voltage side and the car's other systems. For example, it might report data to a dashboard or coordinate with motor controllers, often using serial links like CAN communication. If we connect a communication cable without isolation, then it would be a disaster. Instead, we use isolators on communication lines. So data flows, but the high voltages do not. It's like a carrier pigeon to send a message across a war zone. The message gets through, but two sides never physically meet. This prevents any ground potential differences or surges from high voltage side from frying the communications on the low voltage side. High voltage systems are electrically noisy. There is whining of motors, the PWM switching of motor drives, current turning on and off. So, without isolation, the BMS and everything connected could share a common ground or circuit path, lead to ground loops, and will interfere with sensor readings. A ground loop is basically an unwanted feedback loop through the ground wiring that can create unpleasant noise. By isolating that section, we break those loops. It's like noise cancelling headphones for our circuits, which keeps the nasty interference out of the BMS but still get the accurate measurements of the voltage and currents without random noise spikes. Here, the isolation helps maintain signal integrity in an electrically noisy environment, which is crucial for stable and reliable BMS. Well, if all of our practical reasons didn't convince you, there is the fact that industry safety standards demand for isolation in high voltage systems. Regulations like IEC 60664 for insulation coordination or the automotive standard ISO 26262 for functional safety. Basically saying you should isolate your BMS or you don't make cars. These standards specify things like minimum creepage and clearance distances. Basically, how far apart high voltage and low voltage conductors must be kept on a circuit board, and how robust the isolation barrier needs to be to withstand thousands of volts without breaking down. If we don't follow the rules, best case scenario, design fails certification. Worst case scenario, something fails in the real world and we have a lawsuit on our head. So, to keep regulators happy and our engineers out of jail, we have to isolate as required. Things can and do go wrong. Isolation provides a safety net when faults happen. For instance, if a high voltage line inside the battery pack accidentally shorts to car's chassis or low voltage line, a proper isolation will limit the faults to that particular section only. The BMS often even includes an insulation monitoring device, basically a circuit that constantly checks that the isolation barrier is intact, which measures leakage current between HV side and chassis. The moment isolation starts to fail, the system can alert or shut things down safely. Without isolation, a single failure could lead anywhere, taking out multiple systems at once. Also, isolation enables modular designs. We can have multiple battery modules, each with their own BMS section, all talking through isolated links. So, if one module has an issue, it doesn't drag others down. So, yeah, isolation is needed for whole bunch of really good reasons. It's literally life-saving stuff. In summary, The high voltage BMS is one step forward to what we have already learned, but it is a bit complicated. And we'll see each and everything one by one. If you found this video useful, give it thumbs up, hit the subscribe button, and stay tuned for more exciting content.